everyone. Today we have our another new episode and we will discuss on advance in Nikola Tesla technologies in 21st centuries. We have our world famous speaker, Professor David Smith, and he's going to discuss about Tesla's defense innovations. World Talent Economic Forum focus on Tesla innovations and uplifting the technology. Professor David Smith playing a key role to introducing this technology for emerging technology countries. Professor David Smith.
Well, Dr. Sharif, thank you so much for the opportunity to talk about Nikola Tesla. He was a true inventor that was ahead of his time. Let me start with just a little bit of background on him. He was really a scientist who invented many things, but these included the Tesla coil, alternating current, AC for electricity, discovery of rotating magnetic fields, and so much more. But he came to the United States in 1884. He was born in Europe and came over then. He worked for Tom Edison for a while before the two parted ways. He also sold many of his patents. He was a prolific patenter. He sold those, including his alternating current machines, to George Westinghouse, which formed the Westinghouse Corporation. And when Tesla was young, he was actually spurred on to look at electrical inventions by his mother. And his mother had invented small household appliances in her spare time while his son was growing up. And Tesla's father was an Orthodox priest and writer, and he had asked Tesla to join the ministry, but he followed more along his mother's background and became much more of an inventor. Tesla got his degrees in Germany and moved to Budapest, where he began to start inventing, where he worked for the Central Telephone Exchange for a while. And while he was in Budapest, though, the idea for the induction motor first came to him, and he tried to commercialize that in Europe. But at the age of 28, he decided to leave Europe for America. And he really began to succeed much there. At the time he moved to Madison, Thomas Edison was trying to deploy a direct current-based electrical system, which was becoming the standards. But what happened is Tesla went in with him and said, no, it's really alternating current, which is the one that should succeed there. And so in 1885, Tesla received funding for the Tesla Electric Light Company. And then he also began to develop something called arc lighting. And really began to change the course of where he was heading, what he was doing. Throughout his career, Tesla discovered and designed many different important inventions, most of which were actually patented by others after he did the invention, including the electric generators, dynamos, induction motor. But he also was a pioneer and discoverer of radio technology, X-ray technology, remote controls, and rotating magnetic fields, which rotating magnetic fields is a fundamental technology, which is the basis for most of the alternating current machinery we know today, and how that can be used and how that can be applied. He also began to do many other different things around that area. He finally got some funding. Tesla's AC system caught the attention of the American businessman George Westinghouse, who was trying to seek a solution to supplying the nation with long-distance power. And he thought that, as opposed to direct current, the alternating current could do that. And so he purchased his patents for $60,000 cash and stock in the company. And as Tesla and Westinghouse were there, they were direct competition with Tom Edison, uh, and who was trying to, like I said earlier, market his direct current. But but fortunately for them, uh, they were chosen. Tesla and Westinghouse Corporation chosen to supply the lining at the 1893 World's Fair in Chicago, and that's where it begins starting. Also, Tesla was early to design hydroelectric power plants. His first one in the United States was at Niagara Falls, and it was used to fund Buffalo, New York, with AC power. But one of his inventions that I actually enjoy the most, and I've seen it used many different ways, is he patented the Tesla coil, which laid the foundation for wireless technology and is actually still used in radio technology today. And it's the heart of an electrical circuit is an inductor used in many of it, and it resonates current and voltage from itself. And Tesla used the coil to study not just radio, but also fluorescence, X-rays, wireless power, and electromagnetism in the earth and the atmosphere. One of the real important things that I think is fundamental is Tesla throughout his life wanted to discover a way to transmit energy, electrical power wirelessly, uh, not using the wires like we've used for centuries to transmit it here. And what I also find fascinating is right now there's half a dozen companies which are trying to commercialize this wireless energy projection system. It's really based on the fundamental science that Tesla did in the 1890s and 1900s there. Uh, and he really had a lot of things. The biggest challenge he had was how to get paid for stuff. He did not have a really good source of income, uh, and that uh, was throughout his life. He saw that problem. He was a fantastic inventor. He was not very good at commercializing any of his inventions, and how he can do that and how he can move on it. And you see some of the disclosures going out on it. Um, he, like I said, was a proficient inventor and patenter of the technologies. Um, in some of them, you really have to question where will we be today without some of his inventions, particularly with ones like alternating current and how it's used. Uh, Tesla was awarded the first patent for remote control devices in 1898 using a battery powered boat as a demonstration. And it was controlled by radio signals and put in place. He and Marconi are debated as to which ones invented radio. Uh, Tesla was first to file for a patent on radio. Then Marconi protested and had the patent given to him. And just recently, uh, the patent was reverted back to Tesla. So even the radio, the wireless communications, uh, there was something going back real interesting then that is he began to use something called the violet ray. Uh, when electric therapy was the rage, to say things. And the violet rays was used as a healthcare device through people's bodies. He invented the neon lamp. Uh, he also went back and spent a lot of time talking about the futuristic world at his time of robots. And as he pioneered the first remote control vehicle, he also was trying to look at the ways you can turn that into more general purpose robots. Uh, the induction motor, like I said earlier. The X-ray is kind of interesting. On prior shows, we've talked about Tesla called it a shadow graph, but it is really X-ray is no is has claims multiple people to invent it, but it's no small part about it came into being because of the genius of Nikola Tesla with some throwaway experiments with his discharge tool and others like that. Uh, and he noticed that when he had photographic plates near his experiments with that, he was able to produce the first image of the human body using the X-rays. Again, he called them shadow graphs. And he began to use that. And uh, for example, he made X-ray photos of fish and their skeleton and things. So great inventor at the time. And his legacy really lives on today through many different things. We're seeing today also that people are going back and studying his writings, studying his patents in uh, many, many different ways, um, and how he influenced technologies he didn't even were not even thoughts at the time. For example, he wrote of mobile phone technology and a wireless internet back in 1901. He imagined really the transmission of messages wirelessly before anyone else did. And he just was very interesting that way. He also uh, began to look at different ways to do measurements, which is a fundamental that we still use part of these today, but most people do not give him credit on it because even though he wrote about it, he, in essence, invented parts of it. Uh, he did not commercialize it. He did not take it there. So, like I said before, he was really good about inventing and talking about what he was inventing, but he was not really good about moving it into commercialization. Um, it's also, though, that one of the things that we've learned a lot about through Nikola Tesla is his invention process. And uh, it, much has been written about this, and we're seeing it beginning to be used more and more in time. Uh, it has been written that Tesla had a photographic memory, but as he wrote about it, he said he could envision things in three-dimensional structures in his head, and he could work on them in his head, redesign them. He, in essence, could do mental tests on them in his head before he would work to invent something. So he actually says he was mentally an inventor in his mind first, and then moved it to paper and others. Where most inventors at the time started with paper and tested on paper, then started doing inventions, and then testing went through multiple visions. Where Tesla tried to create the final designs in his head before he applied it. Uh, it's also to me very compelling that if you go back and look at what was Tesla's first invention, he invented a voice amplifier for telephone receivers back in 1881, and uh, that was his first invention. And some of the concepts of that type of invention are carrying forward today in a lot of things. The other thing that it was kind of interesting, when Tesla died, the Office of Alien Property seized all of his belongings. Some of them were sent to his family, some were sent to museums, but actually some of the documents and things received were classified by the government. Remain. So is inventions we do not even know fully about today. Tesla was ahead of his time in some other things as well. Uh, Much has been written by him in his writings that Tesla cared about the environment, and he was very concerned that mankind would soon consume all of the available non-renewable energy sources. So part of the time he spent inventing things, he was trying to invent some alternative ways of developing renewable energy, and he conducted many experiments of this in his labs, and and wrote and documented them. Again, he did not commercialize many of them, but he was there. And he also, though, was such a scientist that he was not concerned about making money out of his inventions, which is the reason why he died poor. His aim was to invent things to make human life better and not just make money out of his intelligence. And he really got by on very little sleep. There's stories of him uh, working 84 hours straight without any rest often. And as I said, he was a prolific patenter. He had over 275 patents in 26 different countries. And he used it in many different ways. Tesla had a ambition to illuminate the whole world, and he also thought that he could use the gases in the upper Earth's atmosphere to carry high frequency electric currents, and he thought he could also use that as a terrestrial night light, where he could create uh, illumination that would be around the world by his energizing the upper atmosphere. And it was really a fantastic concept as you begin to look at it. One that would totally have changed the world as we know it, but he was not successful in doing that. Um, and he has great quotes going back over what he's doing. Um, one of them was a quote from him that said, "The scientific man does not aim at immediate results. He does not expect that his advanced ideas will be readily taken up. His work is like that of a planter for the future. His duty is to lay the foundation for those who are to come and point the way." And that is one of the key things, if you go back and summarize his work, that it was really him there as well. He also, though, believed that some of his best inventions came when he was alone. He was a scientist who never got married, worked very heavily by himself on a lot of the inventions, and he believed that the quiet time to be alone or when ideas were born. And you see that with some of the cultures around the world today being able to practice that. Um, where he is. The other quote that I loved from him is about his methods. And he says, "My method is different. I do not rush into actual work. When I get an idea, I start at once building it up in my imagination. I change the constructions. I make improvements. I operate the device entirely in my mind," which goes to some of the things I was saying earlier, and how those can come back in our thought process today and the elements where we're doing things and create a significant impact on what we're doing. And we've seen the processes change over time, and we see the importance of the individual time. And today we also see the importance of group intelligence. But Nikola Tesla laid the foundation for a lot of these. And Dr. Sharif, I see that David Kelly has joined. So why don't I stop a moment here and pass it over to David?
David Kelly, can you hear me?
I can hear you. Can you hear me?
Yes. Can you open your camera?
Uh, yeah, it'll take me a second, but yeah, give me a few minutes on that. But I can talk in the meantime.
Yes, yes. We are discussing on Nikola Tesla technologies and different innovations. Tesla has any contribution in AI? Can you share with our audience?
He has a contribution in AI.
Yes.
Okay, tell me about it. I mean,
No, I want to.
I'm fairly familiar
I,
with Nikola Tesla, but most of the work I'm familiar with is in electricity and
okay. Okay. You
that's.
can discuss about his innovations in electricities and everything. Yeah.
But AI, I mean, tell me what did he do in AI?
No, I don't know. I'm asking you. You have any idea that he has any contribution for
Oh, no.
artificial
I mean,
intelligence?
his contributions are in the fundamentals of electricity in uh, everything from radio transmission to AC power in particular is extremely impactful, um, uh, and this sort of thing. And without that, our AI would really not be a thing to speak of without understanding the fundamentals of electricity and some of the work that Nikola Tesla did. So in that way, he certainly enabled AI at the and the kind of modern computers that came out of um, uh, I guess the modern age, as it were. But yeah, from my standpoint, Nikola Tesla is one of the enablers that allowed humanity to climb out of the dark ages.
Mhm, mhm. Excellent. Professor David Smith. So, what do you think? Like, as we are facing energy challenges right now, especially country like Bangladesh, those who do not have enough uh, resources, they are definitely facing this kind of challenges. So, what do you think? This innovation can help us, or what is the possible way to?
Well, I think many of his ideas can help us. I mean, if, for example, we talked earlier about he envisioned a world where we could transmit power without a grid. He imagined a world where we can transmit alternating current wirelessly across the world. Uh, he even did an experiment back with his Tesla generators back in 1895, where he sent electricity over 25 miles from where he was generating the electricity at Niagara Falls to factories in Buffalo, New York. And he did that by using his Tesla generators and things. And then, you know, many people were afraid to have that much current transmitting wireless through the air. So Westinghouse actually began to take that and change it to being a wired distribution system. But, that experiment back then established what became part of the electrical industry worldwide. And where we're seeing power used around the world, actually, it can put its roots back to some of the early inventions that Tesla did, some of his deployments, his writing that went forward on using them, and in different ways. Like I said, even like I said earlier, even the remote guidance systems and his writing on robotics were well ahead of his time, because we're seeing some of them he wrote about back in the early 1900s beginning to come reality now, because we have developed the computer technology. We've been able to miniaturize much of the motors and things that he designed in his early days. Um, and we see that being done. The other thing, like I talked about earlier, is Tesla was ahead of his time in that he began to look at what are the impacts on the economy, particularly uh, non-renewable resources. And he spent a lot of time writing about that in his life and becoming at it. I would love to have seen what where would be today if uh, his lab had not burned down. In 1895, the building that housed his labs was 100% burned down. And so in all of his papers and but he was beginning to, um, at that time, beginning to reconstruct everything from memory, because he did have a photographic memory, but that slowed his invention process down quite a bit, uh, in where he was doing things. Uh, the one company that really got in and helped him was J.P. Morgan. Uh, and he funded Nikola Tesla for about $150,000 back then, which is probably worth around $4 or $5 million today, to have him build Tesla build what he thought would be a new type of wireless telegraph that could exchange information with Europe wirelessly. But he was really ahead of his time as you're looking at that. So he built a tower where he was experimenting with using the Earth and the ionosphere to transmit not only communications around the world, like what J.P. Morgan funded him for, but he was actually more convinced of trying to transmit the electric power. And he really got changed that way. And Time magazine actually in 1931 uh, put Nikola Tesla on this cover of it for his 75th birthday as the father of the grid, and really got involved with that. And you see what's happening. There is now a Tesla Science Center at Windercliff, where he was, and it's really beginning to work, and it's to make his papers more available, to make his inventions more available. And like I said earlier in the program, even today we're seeing people studying his work and bringing new products to the market all the time. And so that's kind of where I think we are. So, Dr. Sharif, I hope that answered your question.
Yeah. David J. Kelly, you are also a scientist. You're innovating AI. Tom's 17th of this month, he is visiting Dhaka, and he may join in different universities and with the government agencies and everywhere. So he's also representing AI and innovations. Country like Bangladesh. For us, we have entrepreneurs, and the government has planned to integrate it with these modern technologies and with these things. So, beside this Tesla innovation, if you advise us, I'm sure today's session will many like audience from South Asia, they will attend. But how we can improve this area, how we can get support from your research lab, how we can work together for improving the quality of emerging economy like Bangladesh.
Well, I think it gets back to, you gotta go out and start working on projects. Like, if you want to learn, get in there and learn. Do something. Do a project. That's, at least for me, that's how I generally wrap my head around something new, or something I don't understand yet, or something like that. In terms of working on projects, like right now, we're working on AGI related technologies, and essentially we have all the pieces now with the large language models, and when you start applying cognitive architectures and some of this other stuff, it's not going to, like, tomorrow take over the world or anything. It's what we have now is going to turn into kind of a slow burn singularity, with an intelligence explosion. Just like and for those that really want to take advantage of it, it's good to learn how to do that with just Chat GPT, for example. It's not so much to really make use of it, though. You need to understand the problem you use it to do. Like, for example, I had to write configuration software for every different development environment inside a major corporation, and I was able to do it in 2 hours with using a large language model that wrote most of the code for me. But if I didn't understand what that code was doing, I wouldn't have been able to piece it all together. So and normally that would have taken weeks to do. Um, or like with the research algorithm that we have that uses a cognitive architecture and graph data to build out these complex ideas, and then use a language model to stitch everything together into a research paper on a particular topic that then if we can consume or publish or do whatever we want with it. But being able to take advantage of these kinds of technologies, I think, enables the kinds of projects you can do. Like, for example, you mentioned Tom. If it's the same Tom that I know, he asked me if we would provide an AI running mate for him, and I haven't replied to the email, but we're going to go ahead and do that. And he can do policy analysis and all this stuff and do it on the fly, right, with that AI system that will give him access to. And those kinds of projects can be done relatively inexpensively, but learn the stuff you're interested in and do projects. And like, if you want to work with us, you got to ping me and let me know what you want to do, and by all means, we've got a project for that people could work on if they want. But a lot of it is very technical, so you've got to learn that technology. Take a course, or you don't even need to. There's a lot of free stuff online, YouTube, for example. But you do need to have an internet connection and a functioning computer of some sort. But as long as you've got that, you're good to go.
Yeah.
Well,
Professor
and you
David
need motivation. If you don't have the motivation,
excellent. Excellent. Professor David Smith, what's your advice in this point?
My advice is similar. That the genius of Nikola Tesla shows that if you dream, if you set your mind to looking at things, and particularly with the tools we have today come available, you can be innovative, you can invent, you can look at things around you and begin to try to put solutions in place. I agree with what David Kelly was saying, is that you have to have the tools in place to do it today. Would be hard inventing without the computer, but if you look at all that Nikola Tesla accomplished, this is well before the age of computer. And well before we had global communications and how we could have devices talking to other devices. He pioneered in concept many of those, but the execution had to wait decades and decades for the technologies of the world to catch up. But the fact that he could do this primarily in inventing in his head and then reducing it to paper later on and then filing patents around it is amazing when you consider what the state of the art was during his time in the world, and how it can be used. I mean, today we would look at some of that and say, wow, that was good, but look at the tools he had. He didn't have the tools back then. And to me, that is a perfect way for us to look at even the differences between the developed world and the developing world, in that You don't need to have all the tools. You just need to have the sparks of creativity. You need to be able to connect the dots in your mind and on paper to get the stuff done. And you need to begin to look at the process to get done. The one difference I have with what Nikola Tesla said in some of his writings versus how, as I've worked in research and development throughout my whole life, is I see the power group intelligence. But a lot of our power group intelligence today is enabled by technology. I wonder today what type of inventions we would have from Nikola Tesla if he lived today with all the tools and capabilities we have at our disposal today. You know, maybe he would not have been as much of an inventor. You know, he might have, David, he might have gotten caught on War of Warcraft and played all games all the time. Who knows?
Yeah, but maybe he might have invented warp drive too.
Maybe he could have invented things like warp drive because that was some of his fascinations. And he could be mining energy from the stars today because that was his goal, to create unlimited energy to supply the world with. So, you know, I would love to have seen him inventing today, but he was well ahead of his time back when he was inventing back then, Dr. Sharif.
Okay. Professor David J. Kelly, when we work in the real world, uplifting different technology of Nikola Tesla, we actually visit many universities, research lab in developing world. But it's still, I think, a lot of area we have to improve. Uh, so if we want to develop better research lab and try to uplift this kind of great technologies and innovations, what is your like advice you want to give the universities like in Bangladesh, in India, or in Pakistan, or in Sri Lanka?
I think it's more a matter of the students and the teachers and the people there, not the universities, but those people starting businesses, and be motivated, learn the technologies, learn how to take advantage of them, take advantage of the lower cost of labor or the lower cost of whatever it is you have as a natural resource, and compete online with various things, and drive revenue into those economies. And the more you do that, the more you can then fund larger educational programs, labs, and this kind of thing. I think it's you know, unless you get into government policy and these large sweeping things, it's up to individuals to do it.
Great. Professor David Smith, what the university can do. And another thing I want to add point, like as we are focusing on talent economy, this emerging economy has great brain drain because the talent pool, they do not get enough opportunities in the emerging economies. Uh, they may immigrant themselves in North America, in Australia. Now, many people move in China, Japan. So, how we can overcome from this situation?
Well, you're talking about a flow of people that has been traditional for, I mean, over 100 years, where you've seen the brain drain, as you mentioned it there. But what has done today is that the countries need to really focus on improving the infrastructure, the power infrastructure, the digital infrastructure, the ability to communicate. Universities need to focus just on the basis of trying to instruct students. Um, you know, most universities are still, as you've heard me say before, Dr. Sharif, they're using the uh, the approaches from the time of Socrates. They use a Socratic approach to teach. And universities, the great universities I see in the world today, are changing to be more of a test bed, more of an enabler, to enable entrepreneurship to happen, to enable innovation to happen, not just focusing primarily on teaching during a fixed period of time. You've heard me, Dr. Sharif, talk many times about we're in a time of lifelong learning. And most of that learning is going to happen through areas outside of higher education. You're seeing it today with boot camps. You're seeing it with online education. You're seeing many different ways coming together to be informed and educate. Your program here, Dr. Sharif, is an excellent example of that. You are giving, through your hundreds of programs on this, in essence, a college education to many of your viewers through the topics you cover and other things like that. But this is the type of thing that universities in the developing world need to understand, is their role has changed. And that part of their role is to actually support the innovation in their communities. It is to support collaboration with their colleagues in other cities around the country and other nations around the world, and to look at the hard problems we face today and how to begin to have an impact on those hard problems. And that is where I think you're going to see the next big breakthrough in universities, is those that think outside of their brick buildings with their lecture halls in them, and to see how they can impact the problems of the world, how they can help with economic development, and how they can spur the innovations that are necessary for the future of our world, particularly when you look at sustainability, equality, many of the topics you talk regularly about on the program, Dr. Sharif. And that's how I think many of the colleges and universities in developing nations need to change. We're seeing some of those changes, for example, now in North America colleges and universities. And I hope that it's a good precursor and best practice that can be duplicated around the world.
Mm-hmm. Thank you.
Yeah, I would really want to say what David just said is right. Absolutely agree. The more they can do what he just said, that's probably the fastest way to success. He's absolutely right.
Okay, Professor, let's focus on Nikola Tesla technologies. Like when Tesla, he cannot make enough money for his living, especially in the last part of his life. So, what do you think? Like those who choose this research and innovation area, they have to think in that way that I cannot make enough money through my innovations, or the present situation actually change. Those who innovate, they can make more money and they can make a better life.
Well, during the times of Tesla's life, there was not the structures we have today. You did not have accelerators, incubators set up for technology. Nikola Tesla's inventions came before the time that corporations really set up large research and development centers, which are kind of going away some, but we're seeing them being more distributed. We're seeing an ecosystem set up where you have inventors that then sell their inventions to larger corporations and do it. Nikola Tesla's failure was he did not take the time to market and sell his inventions. He did not take the to take his inventions to commercial, today we would call it commercial viable products, a minimum viable product. And my analogy I like to use is making a cake. He would begin to write about the invention, put the places together, but so he would put kind of the outside the cake together, But David Kelly, I know you know this analogy pretty well, and I think you do too. So it's, let's say you have a cake that's supposed to bake for an hour in the oven, and you take that cake out after baking for 10 minutes, 15 minutes. What you have is it's really gooey in the middle, but you have some of the fundamentals of the crust around the outside. Well, that's what Nikola Tesla did with his inventions. He would bake it just long enough to get a little bit of the crust, but most of the details, the gooey stuff, he did not commercialize. And that was his, if you want to talk about a failure, that was his failure, but he was not concerned on commercial success. I mean, if you look at what he did with Westinghouse, what he did with Thomas Edison, what he did around the radio times with Marconi at that time and others, he was more concerned on being the inventor, being the discoverer, than the commercializer. In today's time, you would have partnered him with other people to form startups for each one of those, and he could still be the chief scientist in today's term. He could still be the chief inventor, but he would not be the one responsible for taking his inventions to the market. And that's how the world, the ecosystem of startups and of inventions have changed from then to now. You know, back then in universities, you didn't see offices of technology commercialization like you do now. So even universities are understanding that if you just invent it, it's great, but you need to commercialize it. You have to do something with it. And that was not understood at all back in the times of Nikola Tesla. And those are some of the things that would have provided him money if he was alive today, versus back in that time, as the ecosystem just wasn't ready for his approach to innovation.
Okay, Professor David Jekali, what's your concluding remarks for today's session? And this coming July, you are organizing very special summit, as well as we will organize training for CEOs. So the speakers, those who regularly join World Economy Forum, I want to invite you all, you as a trainer and as a speaker for this summit this coming July. So I want to invite Dhaka. Professor David Jekali, what's your concluding remarks?
Well, I think my concluding remarks is get out there and get motivated and do something. You know, with the universities and doing things like some of the programs David had mentioned with incubators and startups and that sort of thing. If you want to improve your life and society and the things around you, you got to just start doing it. You know, start a business, learn a new technology, participate in some of these incubation labs and this sort of stuff, and get involved. That's the single most important thing you can do. Talk is cheap.
Thank you. Professor David Jekali, what's your concluding remarks? And we are also want to invite you both in Dhaka Summit. We will organize Talent Economy Summit and special training. And definitely those who publishing a research paper on Nikola Tesla, they will join in this conference. Professor David, speak. Yeah.
Well, Sharif, thank you again for allowing me to be part of this. You know, almost you could take this broadcast today of yours and submit it as a paper for your conference, because we've covered so much of Nikola Tesla and his life and his processes, his inventions today, and the good and what was not so good about his approach and how it would be different today. My comments, I might just echo what I said before, is that with today's capabilities, I really wonder what he could have invented today and what his inventions could be commercialized today with the advances we have today. I think we, as a world, should go back and look at what he invented, look at his concepts, look at his processes, and apply them to what we're doing today. You know, if he had had the concepts of digital modeling back then, if he had had the concepts of digital twins, the computing power to do even the math, he was working on elements like transmitting energy and communications off the ionosphere that today would require many calculations on supercomputers. He was doing it in his head and trying to do those bases. So we have the tools to surpass what Nikola Tesla could do. What we lack is the imagination. What we lack is the ability to shed what our thoughts of, gee, we'd like to solve this problem, but it's a hard problem, to going and saying, well, what if we can solve this problem? How would we do it? Even if it's not invented yet, what would be needed to be invented to do this problem? That is where innovation happens. I'm reminded, I was the code leader of the first industry roadmap done in the semiconductor industry. We did an event there where, on the last day of the conference, where we said, if you put all the constraints aside that we have in the industry, and we think about what we want to do, what would we do? And one of the ideas that came out of that session was, instead of building a semiconductor, can we grow a semiconductor? Well, 20 years after that came up, two different university, well, a corporation and university, both demonstrated that there was a way to grow a semiconductor. And it comes from those times when you say, what if? What if we could do things? Nikola Tesla was a genius at applying what ifs, thinking through it in his mind, constructing it in his mind, operating in his mind before he began to go and put it in operation. And that, to me, is one of the things we really need to do today as we look at how to apply the things we've learned from Nikola Tesla in today's world, and how it can be applied and used. Oh, and I see we've lost Dr. Sharif, but yeah,
He'll be back.
I know. And this is actually one of the things where we should apply some of those intelligences. That how do we increase the stability of the internet? How do we solve last mile problems? How do we begin to look at those elements? David J. Kelly, you missed me earlier on the week. Well, actually, yesterday, we had a part of Texas-wide internet outage.
Ooh.
And, just coming up and seeing how that hurt trying to get into programs like this. And, I had to reboot my modem multiple times to even get any stability. So it's just little things like that which can do it. But the innovations we've seen from folks like this, that is one of those challenges I would love to see the developing world, because they're inversely impacted by the needs. Solve the problem.
They can skip a lot of the crap that we've done too, and just skip to the best solutions, like with mesh networks and things like that, instead of the trillions we've invested in hard lines that now are just not cutting it.
That's right. And the wire and spoke distribution with the mesh networks would be fantastic there. But Dr. Sharif, there's just so much that can be done. We can learn so much from what Nikola Tesla did. And we have problems today that his approaches can be applied to if we just find the right innovators and the right entrepreneurs to commercialize it and move forward with. So fantastic opportunities. His works are his writings are increasingly becoming available online. I would encourage people to scan them and try to get ideas and use that to help change the world. And that's my concluding remarks, Dr. Sharif.
Thank you. Thank you, Professor David J. Kelly and Professor David Smith, for your continuous support for World Talent Economy Forum. I request you all to share our content with the government agency, corporation, and academy. And definitely this time in our summit, in our CEO training program, I want to invite you all. We have a very good sponsor to support your travel in Dhaka. Thank you, everyone. Thank you. Bye bye and
Thank
take
you.
care.
Bye, everyone.
Bye.